Okay, so let us discuss another method of solving deflection. Since nahuman naman nato og discuss ang concept sa area moment, it will be easier for us na ma-perceive ang pamaagi sa superposition method. Because ang gigamit sa superposition method is ang foundation sa area moment method. Okay, so katong niagi gipa-derive na ko sa inyo ha ang formulas, no? Ipa-derive na ko sa inyo ang formulas, deflection formulas using area moment. Okay, so natay lahi-lahi ng mga formulas, and ang technique sa superposition is you have to memorize the formulas. You have to memorize. So as much possible dili lang ninyo i-restrict yourself sa katong mga gipa-derive nako, no. It would be better if daghan pa mog formulas nga nahibalan, deflection formulas, so that on the board exam dili na mo kinahanglan mag-derive. Okay, so unsay concept sa superposition? In a superposition method of solving deflection, you have just to equate the, say for example, you have this type of beam. Okay, prop beam, I mean a cantilever beam. Kung nakay load dire, nakay deflection, diba? It will have a deflection, a downward. So kung ang cantilever beam himuon nimo siyang prop para mahawa nimo or makuha nimo ang iyang deflection sa iyang end, so you have to apply a support, let's say a ruler. So a ruler will equate the deflection. So instead nga na kay y1, the support will offer a resistance that will delete, or that will so that the beam could not have the deflection y1 or y sub 1. Mo resist siya sa y1, so wala na deflection. So the load here offers a resistance equal to y1. So instead nga na kay deflection, iyang ibalik dito pasaka, mao nang ma-equate nimo ang mga equation. Okay, so y1 equal to y2. Ingnon na to, ang imuhang beam is, imong load is uniformly distributed. Okay, so may deflection formula ani. So the deflection formula for this is WL to the 4 over 8 EI. Then butangan nimo siyang support to delete the deflection, no? So pila man ni, that is a concentrated load at the end. So that is PL cube over 3 EI. Okay, so deflection here is equal to resisted nga deflection, no? Ang gi-resist nga deflection. So ang concept sa superposition, gina-equate lang ninyo ang deflection caused by the load at the top sa resistance, deflection offered by the resistance or the load, no? i-equate nimo ang sa ibabaw sa ubos. Ana lang, equating the deflection formula at the top sa deflection formula nga kuha na to, no, kita na to nga depende pud sa imong support. So nga no, ang ginagamit niya is ang maximum deflection formulas. Okay, so take note nga natay daghang pamaagi sa pag-solve og deflection, pero every method, every technique is more applicable depende sa sitwasyon. Say for example, in a simply supported beam, mas convenient gamiton ang area moment. But for the superposition method, it is more convenient to use on a prop beam or a cantilever beam. Okay? Although magamit gihapon siya sa kuan, magamit gihapon siya sa area moment, pindi lang, pero pinakagamit gid siya kung prop beam ang imuhang problem. Okay, so take note for that. Kung prop beam, it would be easier to use superposition method. So let us have this example. We are given here with a beam having a span of 6 meters supported by a ruler, a cantilever beam supported by a ruler, that is prop beam, at the right end. It carries a load of 400 kilonewton per meter. So throughout the span, EI is 1 million kilonewton meter squared. So number 1, what is the nearest deflection the right end if the roller support is removed? So kung wala roller support, it would simply be this one. So that is deflection is equal to WL to the 4 over 8 EI. We have 400. If you convert kilonewton per meter into meter, multiply by 1,000, makancel. So still, 400 is newton per millimeter. Okay, then the length is 6,000 mm to the 4. 8 EI is 1 million. But kilonewton meter squared, you have to multiply 1,000 for the kilonewton and 1,000 squared for meter para ma-convert siya into newton mm squared. So that is 1,000 cube. Okay, so deflection is using your calculator, 400 times 6,000 to the 4 over 8 times 1 million times 1,000 cube. So we have 64.8 millimeters. So imagine, naka-length nga 6 meter, in actual kung walay ruler, ang deflection lang gyud niya using this EI, using this modulus of elasticity and moment of inertia, or the rigidity. So gamay ra gid kaayo no. So yun lang kanang 64.8, so that is 6.48 centimeters out of the 6 meters. So pila lang nakasa ka percentage. So ang deflection na to is almost negligible sa atong eyes, no, kung tanaw na to siya visually, kung i-actual ginato ni. Okay. So number 2, using the superposition method, what is the deflection at the right end if one unit upward force is applied at the right end of the ruler when the ruler is removed? Okay, so 1 unit upward force, that is kung ang imuhang beam na to upward force nga 1 unit, so that is PL cube over 3EI. One unit upward force. Okay, then we have the length 6,000 cube, 1 million times 1,000 cube. So we have 7.2 times 10 negative 5 mm. Okay, so ang pangutana is not this one, no? Ang pangutana sa problem is pilay mabilin nga deflection once nga applied ni. So ingno to, nagbutang kag 1 unit nga resistance, mo deflect unta si beam. Without this one, mo deflect unta siya o y sub 1. But due to the resistance offered by the 1 unit concentrated load, nius-us ang imuhang deflection, no? Ni imbis nga dako siya, gamay na lang. So that resistance offered by the 1 unit, na to, this is y sub 2. Ang nabili na lang ang gipangutana, that is y sub 3. So y sub 3 is equal to y sub 1 minus y sub 2. So that is 64.8 mm minus 7.2 times 10 to the negative 5. So almost negligible lang ang effect sa 1. That is 64.79999 mm. Okay, so for number 3, which of the following gives the reaction of the roller support in newtons? Okay, so since dili man enough si 1, pila magyud dapat ang atong resistance, no? Pila gyud dapat ang resistance nga ibutang nato para walay deflection nga mahitabo, no? Para walay deflection nga mahitabo due to the 400 kilonewton meter. So pila gyud value sa P. So ang pamaagya na is to equate, no? The deflection offered by the deflection caused by the load should be equal to the resisted deflection due to the application of the support. That is uniformly distributed load on a cantilever, that is WL to the 4 over 8 EI equal to concentrated load at the end of a cantilever. Kung tanggalon ni mo na, that is concentrated load on a cantilever, that is PL cube over 3 EI. So pag mag-equate ka, you can always simplify. Cancel the EI, cancel the L cube. What is left here is 1L. So you have WL over 8 equal to P over 3. So we can extract P. So that is 3 over 8 WL. Okay? So P is 3 over 8, 400 times L, 6 meters. So 3 over 8 times 400 times 6. So that is 900 kilonewton. So you need a 900 kilonewton concentrated load, or you have a resistance or a reaction of 900 kilonewton to resist or for the deflection caused by 400 kilonewton per meter to be 0. So diha nato makita nga superposition method is very important in computing reactions on a prop beam. Reactions on prop beam, superposition. Okay, take note for that.